Well, hello everyone. Thank you for joining us for today's webinar entitled Kubernetes for the Rest of Us. I'm joined by Bob Walker today. My name is John Bristow. I'm the Community Director here at Octopus Deploy. Thank you for your time and attention. We really appreciate you joining us for today's webinar. Before I kick things over to Bob, I just wanted to take a few minutes here to share with you some information about what we have available for you at Octopus. Don't worry, you're in the right place. This is a webinar, and you signed up here at our website, which is octopus.com/webinars. There you'll find other webinars that you may be interested in. So later on in June, we've got a webinar featuring Michael in talking about the Octopus Deploy app for GitHub. We've got the 101 series, which we do monthly, which will be on June 13th. And then we've got a really exciting webinar coming up with Kit and Rob talking about deploying your first application using Kubernetes and Octopus Deploy. Again, that's at octopus.com/webinars. Make it a bookmark, if not your homepage. It's a great resource for you to check out. Another resource to check out, of course, is our YouTube channel. So for those who are wondering, this is a live webinar, but it is being recorded, and you will find it up on our YouTube channel after today's presentation. So you can check us out at /octopusdeploy. And in addition to that, we have some other resources as well. So if you're all curious about what we do at Octopus and how we work well with Kubernetes, you can check out our website at /Kubernetes. This will give you a rundown of everything you need to know about Kubernetes, and you can check it out there. And we've got a whole bunch of resources there, including a white paper, which I'm sure Bob will talk about as well. I mentioned CodeFresh earlier. You can go check us out at codefresh.io. This is a great way for you to get exposed to what we do there in terms of Argo CD, etc. If you're doing anything with GitOps, this is a great resource for you to check out, and let us know what you think. And then in addition to that, we also have our community resource. We have a Slack channel with over 6,500 members. It's awesome. A lot of folks talking a lot about what we're doing at Octopus. You can check us out there. We've got links to our webinars and blogs, etc. All worth checking out. And then finally, lastly but not leastly, there is our roadmap. So this is at roadmap.octopus.com. If you're at all curious, you can check this out. This is a great resource for you to take a look at what we're thinking about, what's coming in the product, anything that's under consideration, stuff that's planned, or anything that we've released. The great thing about the resource, this resource here, is that you can actually go on to any one of these items and you can actually take a look at a detailed view of what's in this item. And then more importantly, you can actually vote down here what you think, how important this item is to you. So you can check out this and let us know. If you have any ideas and you want to submit an idea, you can also submit them there. Again, that's at roadmap.octopus.com. All right. Well, without any further ado, I'd like to turn things over to Bob. Just as a reminder, this is a live webinar, so feel free to use that comments pane. Let us know if you have any questions. Bob and we'll take a time to answer them live here. But with that, Bob, over to you.
Awesome. Yeah, thank you very much, John. Yeah, we're gonna discover how live it is because I think I have a package coming today, so hopefully my dog doesn't bark up a storm. I'm really excited to be here. This is a topic that I really enjoy talking about, so I'm just going to go ahead and jump right in. So before I get started on the webinar too much, if you're interested in getting in touch with me, please feel free to reach out to me on the socials that you see up on the screen right now. And also feel free to reach out to me on email or the community Slack. You can just find me under Bob Walker. Just look for the little octopus next to my name, and that will be me. So you can see I've been with Octopus Deploy since 2018. But I was a developer prior to joining Octopus Deploy for over 15 years. In fact, my very first job was converting classic ASP pages to ASP.NET web applications. And I come from that world of .NET, C#, hosting applications on IIS. And when I joined Octopus Deploy, I was exposed to a whole world of other application hosts, including Kubernetes. And so I had to learn Kubernetes, and I had to learn all the intricacies of how it all works out. And so I really wrote this webinar for anyone that was like me, who had a minimal amount of knowledge of Kubernetes. You're aware it exists, you're aware containers exist, but I wanted to write this from a developer point of view. Because oftentimes when I read the various materials, when I watch a lot of different videos, it seems to be written from a operations point of view, which it's a good thing, but it can get really down into the weeds. And so my goal today is to answer this question of, I built a container. how do I run this on Kubernetes? And you might be thinking to yourself, well, this is kind of the job of platform engineering to worry about that. They've told me repeatedly, all I need to do is provide them with a container. But when we look at what platform engineering does is they can help short circuit a lot of that knowledge that you have to worry about. And they'll do that by providing you the manifest files or the Helm charts or the customize or whatever the case may be. And this can shortcut it. And this can be a better approach than having to go through the hard way and learning about all the pitfalls and how to host a Kubernetes cluster and how to install it and how to install all the different modules on top of it. But unfortunately, when you do something like this, you end up with a situation where you have this try it now, where, hey, this isn't working, and then you notify your operations person, you notify the person that's responsible. They'll go off, they'll do a bunch of work, and they'll come back and say, try it now, and then it works. And you're like, I have no idea what they did. Conversely, it's the let's pair. I know so much about Kubernetes, I can help you solve all these problems. But I think there's a healthy middle as developers where we can have this nice compromise between knowing a little bit about Kubernetes, but not knowing so much about Kubernetes that you have to worry about how it's hosted and everything along those lines. And that's really what the point of this particular webinar is for. And so the way that we're going to do this is first we're going to start with a brief primer on containers. I know that some folks on this webinar, most likely they already have pretty extensive experience with containers, but not everyone is in that same boat. Then we're going to move on to why people are hosting their containers on Kubernetes. Then we're going to talk a little bit about why we should modify Kubernetes and what we have to do to get an application up there and how do we modify it. We'll take a brief detour into GitOps, but it'll be ever so brief. And then we're going to spend a lot of time talking about how do we host that application on Kubernetes. And then finally, we're going to wrap it up with some of the things that you can do to continue on your journey as, say, a developer or someone who's interested in learning Kubernetes but doesn't want to know everything possible about Kubernetes. So let's first start off with a brief primer on containers. And really, containers are an iteration of what was started in the early 2000s into the mid 2000s, which was when we went from physical machines to virtual machines. And I sound like an old man when I say, well, back in my day, if we wanted to get a new server, we had to submit it to procurement. We had to wait for operations to get the machine from Dell or some of those other companies, build it out, slide it into the rack, and it would hopefully everything would work as you expect it to work. And as you can imagine, with such a large lead time, we would grossly over provision these servers. Instead of saying, well, we really only need 2 CPUs and 4 gigs of RAM, we would do stuff like, well, we need 16 CPUs and 32 gigs of RAM. And with virtual machines, we started down this path of hardware efficiency and this scalability. But one of the challenges that has occurred with virtual machines is that every virtual machine looks the same, but is just slightly different. And I like to think back to tract housing in the United States. And if you're not familiar with that, that's perfectly fine. In the United States, what we have is we have these land developers that will buy up these massive amounts of land, and then they'll start building houses. As a way to save money, they'll just reuse the same blueprints over and over and over again. And so when you go down the street, you'll see this basically it looks like the same house. And in fact, I live in a neighborhood that was built like this even back in the 70s. And so I'll see copies of my house throughout my neighborhood. And if I were to go into them, it's like going into a bizarro version of my house. Everything is close, but it's not quite the same. And so we'll see the same thing happen with virtual machines, where everything is close, but there's just some slight differences, and it's just enough that could cause an error, especially as we move between different environments. On top of that, as we add scalability into the equation, it can get really hard to scale out your virtual machines, especially when you want to scale horizontally, not vertically. And so this is where containers come in, is they're designed to solve this, these two big problems, where we're going to have this consistency between all of our different applications because we're building in the libraries, the exact version of the library, along with our source code, and that's going to be the artifact that we're going to give to something like Kubernetes to go ahead and run. It's also going to make things very easy to scale horizontally because we can just add more copies of the same container over and over and over again. Now I have up there is think of containers as immutable pre-built mini VMs. I know that some folks are on the webinar are probably pulling their hair out, going, "No, that's not what they are at all." Again, if you're coming from a Windows or Linux world, this is a good mental model, but it's not exactly like that. So, like I said, just think of it like this, but not exactly like this. The biggest thing to make note of is that containers are immutable. And why I call this out specifically is I still will see emails or questions or requests that will come in and they'll say, can you put, say, a tentacle on one of our running containers? And I'm like, why do you want to do that? They go, oh, we want to modify the container. We want to deploy new versions of our application to a running container. I'm like, that's not how containers work at all. They need to be immutable. If you need to make changes to it, specifically in the source code level, you need to build a whole new container. And this is just one of the changes that you have to make when you move to containers. It changes not just how you build and test your application, but even how you host it, regardless of the host that you pick. Because you might have a situation where your containers could just randomly fail and restart for any reason, so they need to be stateless. Or if they're not stateless, consider making them stateless because your world will be a lot easier. Instead of worrying about how many VMs, now you're worrying about how many replicas of your container. But how you build and debug, how do you remote in and debug? It's not just like how it was with virtual machines. Things have changed. And now your platform engineers and your operations people and your DevOps engineers, they're coming up with new ways to get you the same information without providing the capability to remote in and debug. And once you have a container built, then you need to host it somewhere. And honestly, there are a lot of different options that are available. If you prefer AWS, you can use ECS, or you can even host containers on Lambdas. There's certain situations where that makes a lot of sense. You can host containers on Azure Web Apps or Azure's ACS, but there's also Docker Swarm. But I would say probably the biggest dog, so to speak, in the yard is going to be Kubernetes. So let's jump in why people are picking Kubernetes. So first up, Kubernetes is an open source hosting platform that's owned by the CNCF. And it was originally created by Google based on 15 years of running those production workloads. So when we talk about scale, this is the type of scale that it was designed for. But although it's meant for a massive amount of scale, and if you go to any major cloud provider, Azure, AWS, GCP, any cloud provider out there basically has a version of Kubernetes. You can also run it at a very small level. There's options like Minikube or K3s. One of my colleagues, Sean, he hosts Kubernetes on a Raspberry Pi cluster. So it's completely possible to make it as small as possible. You can also self-host it in your own data centers. So if you opt for tools such as Rancher or OpenShift, that gives you that capability. The picture that's up on the screen right now, this comes from an article that was written about Chick-fil-A, where they're hosting Kubernetes clusters in each one of their restaurants, and they're running them on Intel NUCs. They'll unfortunately probably have to change their supplier because Intel doesn't make NUC anymore. But you can see now where Kubernetes is popping up in new and interesting places every day. And one of the other benefits of Kubernetes is it's very extendable. And it's constantly changing. And in fact, we'll talk about one of the changes later in this presentation. And for cloud providers, they have a monetary incentive to make the plugins work really well. So for example, it was really easy for me to spin up an AKS cluster and connect it to Azure SQL and Azure File Storage, because Azure has a very legitimate reason for making that as easy as possible. So there's a lot of different opportunities and a lot of different options out there to make Kubernetes behave how you want it to behave. And we're seeing this become this dominant container platform. Now, these figures are coming from the CNCF directly, so I always take that with a bit of salt when something that's owned by, like a product is owned by a company and they also release a survey. You can take it with a little bit of a grain of salt on something like that. But some interesting numbers have popped up from those surveys, as well as the Stack Overflow developer survey. I think the big thing to take from here is that Kubernetes has a pretty wide breadth of adoption, but not a significant amount of depth of adoption. So a lot of companies are using it, and some of them are using it even in production for a few of their application workloads. But there's still a lot of other applications that need to make this transition. Now, while Kubernetes is fantastic, it's not always the sole application host. So let's talk about Octopus Cloud for a brief second. Within Octopus Cloud, every customer, they get their own instance of Octopus Deploy. We host it as a container running in an AKS cluster. Now, we also have a database backend and file storage. Well, we could host the SQL Server and file storage in that Kubernetes cluster, but honestly, for our use case, it didn't make a lot of sense. We opted for managed services, primarily because we would have to become DBAs to host host SQL Server in a Kubernetes cluster, and we'd have to build a lot of the functionality that Azure SQL already has. So, like, why would we rebuild it if it's already there? And chances are it's probably going to be better than what we build. Same thing with Azure File Storage. We'd have to become file storage experts. So we opted to leverage managed services in that particular case. So your application architecture doesn't always have to run exclusively on Kubernetes. Pick the best host where it makes a lot of sense based on your own individual requirements. Now, one of the other advantages of Kubernetes is it offers much better hardware utilization. I was talking about this earlier with the shift to virtual machines. Go back to Octopus Cloud. So at any given point in time, we have about 1,900 instances, sometimes more, sometimes less. And if we looked at Octopus Cloud v1, well, back then in 2018, every customer's instance was on a dedicated virtual machine. So if we had the same numbers as we do today, we're talking 1,900 virtual machines that we'd have to manage. On top of managing it, we'd also have this substandard utilization, because at no point would we have a situation where all of the virtual machines were used at 100% all the time. And in fact, we would see this with cloud providers. They're betting on this fact. And so we're spending a lot of money for unused CPU and RAM resources. The other big problem we had was with virtual machines in the cloud is that you can't incrementally increase the resources. It's always a doubling. You always are going from something like 2 CPUs and 4 gigs of RAM up to 4 CPUs and 8 gigs of RAM, and then 8 CPUs and 16 gigs of RAM. There's no good space in between, but what we were seeing is for some of our customers, they just needed just a little bit more resources. They didn't need a whole new size of VMs. So with Octopus Cloud v2, those problems were solved. And now we're hosting those 1,900 instances on 8 Kubernetes clusters. We use virtual machine scale sets under the covers, so we have anywhere between 3 and 6 nodes, sometimes more, sometimes less. So we're talking about 24 to 48 virtual machines. And these are pretty big virtual machines. They're much bigger than what they were back in Octopus Cloud v1. So we're talking about north of 20 virtual CPUs and north of 120 gigs of RAM. But at the same time, we get much better utilization across the board. And we still have other concerns to worry about, not just how we're hosting the actual instance itself. Now, if you're coming over from a cloud provider, and if you have experience with Azure, AWS, GCP, or anything else, a lot of the lessons that you've learned there can be applied to Kubernetes clusters. Because in a lot of ways, a Kubernetes cluster and a cloud have a lot of overlap between one another. It has its own internal network, it has its own secret store. You have to worry about ingress and service accounts and identity access management. So it's not exactly the same, but a lot of the core lessons that you've learned can still be applied with Kubernetes. So it's a good thing. Once I started realizing this, I'm like, oh, now it all makes sense. Now, one of the cool things about Kubernetes is I mentioned that it abstracts away the underlying hosts. And so what I mean by that is that under the covers, Kubernetes is running on Linux virtual machines for most of the cloud providers. You can run it on Windows virtual machines, but that's atypical rather than typical. But as far as the containers themselves are concerned, they never interact directly with each of those virtual machines. Instead, they're interacting with the control plane. And so we decouple our applications from the underlying hosts in this sense. So we can increase the number of nodes or the number of virtual machines, and the applications they're not even aware of that. Same thing, we can increase the number of applications, the number of replicas, anything like that, and the underlying nodes, they really don't know too much about what's going on. Really, it's the control plane that's providing that abstraction for us. Another big advantage of Kubernetes is it leverages this desired state. And the best analogy that I like to use is the climate control inside of your car. So you'd set it to 70 degrees Fahrenheit, not 70 degrees Celsius. We're not trying to boil you alive. But if it's too cold, it will turn on the heater. But if it's too hot, it will turn on the air conditioner. And so it's constantly checking the temperature over and over again. It observes the temperature. It says, oh, what's the diff? And then I'm going to act on this. And Kubernetes behaves a lot in the same way. So for example, let's say that we had 7 copies of our application running. And for whatever reason, 3 of those copies were destroyed. And this can happen within Kubernetes. It's another reason why it's good to make your application stateless. It doesn't happen all the time. I mean, obviously, you don't want to have your applications just being killed randomly, but it can happen. Kubernetes will see that if it does occur, and it goes, well, you said 7. I'm going to go ahead and create 7 containers. I'm going to do my very, very best. And then if it can't do that, it will start sending out alerts and it'll start notifying you and logging events that we can go, oh my gosh, something right isn't going on. So this is known as the Kubernetes control loop. So this is a really important thing to understand as to how we make changes into Kubernetes. It observes the current state and compares it against the desired state. And then if there's any sort of difference, it will generate a diff, and then it'll act upon that diff. And so when we want to modify Kubernetes to host our application, that's what we're going to have to do, is we're going to have to change that desired state. And the reason why I'm bringing this up is because changing Kubernetes and deploying applications to Kubernetes, they follow a similar pattern. So once we get familiar with this, everything else should hopefully fall into place. So if you're like me, I come from a virtual machine world, and you also know that deploying to virtual machines can be very, very tricky. You have to provide very detailed step-by-step instructions. And you have to sit there and you have to watch it to make sure that it's behaving as you want it to do. In a lot of ways, it's a lot like telling a 5-year-old to make you a peanut butter and jelly sandwich. Because if you don't sit there and you don't watch them and you don't give them very explicit instructions, who knows what you're going to end up with? You're going to probably end up with a sarcastic sandwich where it's jelly on one side and peanut butter on the other side, and then the bread is the middle part. And so with Kubernetes, it's a lot like going to a sandwich shop and telling the person there your order. I want a peanut butter and jelly sandwich on wheat with smooth peanut butter and raspberry jelly. You can go off, you can grab a Coke. A couple minutes later, you come back and you got yourself a sandwich. You don't have to sit there and watch it like a hawk. You can trust that it's going to do the job that you expect it to do. And the way that this is accomplished is via the Kubernetes API. It's kind of uncommon to make changes to the Kubernetes cluster directly through the API. More often than not, you're going to be accessing the Kubernetes API through the CLI, which is known as kubectl or kubecontrol, depending on what side of the fence you want to fall in on that argument. And you can make changes to the Kubernetes cluster using the CLI. You can say, hey, I want to create a new namespace, and it'll go ahead and do that. But what's much more common is creating these manifest files. And chances are, if you have any experience with Kubernetes or any sort of exposure, you probably run across 1 or 2 manifest files. It's something that's written in YAML, and it's what you're doing there is you are defining your desired state, what you want it to be. Now, there's a few other tools that are out there. Probably the most common other ones out there are Kustomize and Helm. But what they are is they're really just wrappers around this concept of manifest files. They are modifying under the covers the manifest file in such a way, and then they're going to send it to kubectl. If you are familiar with .NET Web Config Transforms, Kustomize is basically that, but for Kubernetes. Whereas Helm is more like a package manager where you can package in a few other applications, give it a version. There's a bunch of other functionality that goes along for the ride. I'm not going to spend a tremendous amount of time on Kustomize and Helm. I'm really going to focus in on the manifest files, because once you understand the manifest files, Kustomize and Helm will kind of just flow naturally to that. So when you want to deploy your application to Kubernetes, what you're doing is you're modifying that manifest file. You're telling it, I want you to run a new version of my application. And again, it goes back to that control loop. We are changing the manifest file. We're going to give it to Kubernetes. It's going to see that difference. It's going to then act upon that difference. So let's jump over to my Kubernetes cluster, and I'm going to show you how this occurs. So first up, I have an application, and right now it's running 0.1.92, and I also have I just have a phrase that I've passed in as an environment variable called demo. So we can see that here I'm running 0.1.92, and that's what I've given Kubernetes. If I come into my command line, kubectl describe, we can see that's the version that is actively running right now. So if I wanted to change this version, what I would have to do, if I was doing this manually, most of the time it's going to be automated, but if I wanted to do this manually, I could go to, say, Docker Hub, where I have this container hosted, grab the new version, I could paste it in. And let's say I also want to change the secret. So I'm going to go here and I'm going to change it to demo webinar. Go ahead and save this. And then I'm going to do kubectl apply. And I'm going to give it the file. And we can see it's gone through and it's done some changes. And it's very async in this sense. And so now what I have to do is I have to do kubectl get pods. And so now I can see the current version of my application, that 0.1, whatever that's currently running, that's currently here. And now we have a new deployment that's been spun up, and this represents the new version that I wanted to deploy. And this is one of the really cool things about Kubernetes, is it does kind of this blue-green staging style deployment where it's going to go ahead and it's going to spin up a new version, but before it destroys the old version, it's going to go ahead and make sure it's working. And so now, as I was talking, it downloaded it, and now I can see that the old version, this one, has been destroyed, and now we only have this one copy running. And if I come back to my website, refresh it, I can see the new version, and I can also see the new phrase that I've provided it. And the interesting thing is, essentially, when we comes to deployments to Kubernetes, that's a lot of what it is. It's updating this manifest file to the latest version that I want to deploy, and then running kubectl apply. And if I wanted to roll back, all I would have to do is I could just change this back, hit save, and then I could do kubectl apply, and then I could just run kubectl get pods, and we'd see a new deployment going ahead and kicking off. We'd still see the old version running, but now we have a new version it's downloading, and because it already has the container, it should go pretty quick. And so now we see the new version, or excuse me, the old version that's occurred. So that's one way you could do rollbacks. There's a few other ways, but that's a nice, easy way to kind of, again, wrap your head around how Kubernetes works. So when it comes to the deployment pipeline, how it all works, what I essentially showed you was, quote unquote, the last step in the process, where I have my manifest files, or maybe I have a Helm chart or customized, whatever the case may be, and I want to get the latest version deployed to Kubernetes. So I'd go ahead and push that. But what you're doing is you're telling Kubernetes the version that you want it to download from your container registry. Now, by default, it's going to go to Docker Hub, but you can provide any number of different container registries that are out there. So I told it to download that particular version. If I told it to download version 3.4.2, it would go to the container registry and do that. But something still needs to update the container registry. So your build server, that's not going anywhere in this particular sense. You still need something to monitor your various application source code files, and when it detects a change, it needs to build the source code, run the appropriate tests, create the image, run any sort of analysis, and then assuming everything still works, then you push it up to the container registry. So maybe we'd have a new version 3.5.1. But this is where there's some divergence amongst the community, where it's what updates that version 3.5.1. How do we get that latest version saved into that manifest file? And there are a number of different options that are available. You can use a GitHub action, you can use Jenkins, you can also use Octopus deploy to handle some of this stuff. So there's a lot of different options to do that particular work. And then once you've updated it, you then need to call kubectl apply. So once we updated it, however we want to update it, we then save it, we then push it up to Kubernetes, and now we have a new version, 3.5.1. So now let's take a brief detour over to GitOps. And you might be thinking that, well, GitOps and Kubernetes, in order to do GitOps, I need to be using Kubernetes, or in order to be using Kubernetes, I need to be doing GitOps. The truth of the matter is that's not true. You don't have to be doing GitOps if you want to deploy to Kubernetes. It's an approach that you can take, and it definitely saves a lot of time, and it makes a number of things easy, but it's not the sole thing that you can do. And you don't have to use Kubernetes if you want to do GitOps. And in fact, if you look at the 4 principles of GitOps, nowhere does it state that you have to be using Kubernetes. But there's a lot of overlap, and a lot of functionality makes it really easy. So for example, we show it as declarative. And what that means is that you have to have a desired state. Well, Kubernetes operates on that. You have to store that desired state somewhere in some sort of state system or version control. Commonly it's Git, hence the term GitOps. And then once you save that desired state and it's been approved, then you need something to automatically apply those changes to Kubernetes. And then finally you need something to monitor your desired state that's in Git, your desired state that's in Kubernetes, and then the current state, and then alert on any sort of a divergence between all of that. So that word salad, essentially what that means is at the very last step when we have this, we want to push version 3.5.1, what we're changing this to be is more of a pull-based deployment where you're having something monitor Kubernetes, or monitor Kubernetes and Git, and then pull any sort of changes in. And so this is where a tool such as Argo comes into play, because you install an Argo agent that would monitor your Git source code, and you can tell it to automatically apply those changes to your Kubernetes cluster. But again, ultimately what these solutions are looking to do is to automate kubectl apply. And so what you're going to see is kind of this pull versus push approach to deploying to Kubernetes. So from a pull approach, we're talking tools like CodeFresh, Argo CD, and Flux. From a push approach, you're talking Octopus deploy, GitHub Actions, and Jenkins. Although with a number of changes that we're making, as well as our acquisition of CodeFresh, Octopus deploy is now straddling that line between pull and push and giving you kind of the option as to being able to pick whatever works best for you. And hopefully it works as intended. All right, so now let's talk a little bit about hosting an application in Kubernetes. Like, what do we have to build out? So again, Kubernetes is a mini cloud. So think about this as we're building out our application. So if you were hosting an app like an AWS Lambda, you would have to create that Lambda, and then you need some sort of way for traffic to get to that Lambda. So we're going to have to solve that same problem. Now, one of the more interesting things about Kubernetes is in order to do a deployment, like when I had to do my deployment for the very first time, there was a lot of different things that I had to learn and understand. And this is one of the challenges of Kubernetes, is that you often have to front load a lot of this knowledge before you can even do this first deployment. And hopefully I can short circuit some of that for you. But again, this isn't something that's just like, oh, I can just right click deploy like you used to. All right, so I like to do this using diagrams, and hopefully it makes a lot of sense. So we have our container. We want to run it inside of Kubernetes. And then we have developers like you and myself, you and I. We're the types of folks who like to program with our shades on indoors. I actually do a developer like that. So that's when I saw the icon, I couldn't help myself. I'm not that person. I just knew someone like that. I thought it was funny. And so I have my container, and I want to run it in Kubernetes. The very first thing that I need to do is I'll need a pod to host that container. And so a pod, what this is this is an environment for running my containers. It's meant to represent a single instance of my application, and I can have 1 to n number of containers running inside of a pod. But again, that's supposed to represent a single instance of your application. Now, generally, you're probably going to have a component or a pod per container. I wouldn't say it's uncommon, but it's more common to have one container per pod. You typically go the multiple container route if everything is so tightly coupled that you can't decouple it appropriately. This is the only way to do it. But again, remember, your pods are meant to be relatively ephemeral and disposable entities, meaning they can be destroyed and restarted at any given point in time. And you can also set CPU and RAM limits on each of these containers. So I want to take a brief detour and talk about that. So you can set resource limits, very similar to like a virtual machine where you set, I want to have this much CPU and this much RAM. But with Kubernetes, it's slightly different, where you will specify a request and then a limit. So it's basically what your initial resources can be and then how much you can scale up to. Now, in terms of CPUs, typically you'll see things in using M, which can represent millicores or milli-CPU, depending, again, what side of the argument you want to come down on that. So if you see 150 M, what that means is 0.150 vCPUs. So you're just given a fraction of a CPU. So if you see 1000 M, that means 1 virtual CPU. Now with RAM units, it's measured in very common things that you already know about: kilobytes, megabytes, gigabytes, terabytes, etc., etc. However, there's two options. There's the fixed point, which just uses E, P, T, G, M, and K. So if you do 1K, that means 1000 bytes. Or you can do the power of 2, the binary math that we all know and love. So if you do 1KI, that means 1024 bytes. If you do 1.5 gigabytes, that means 1536 megabytes. So a couple things to make note of is that if you do go in and start setting limits, likely they're going to be wrong. I hate to break it to you. So you'll have to monitor the actual usage. And this is a challenge that we actually face with Octopus Cloud, is that we're constantly changing the units based on any sort of different use cases and everything like that. Now with CPU limits, there is a growing chorus that's out there, so something to keep in mind, that they're saying that you shouldn't be setting CPU limits. I'm still reading through that, but I just wanted to point that out to you, that some folks believe that you shouldn't set CPU limits just based on how they work. But RAM is just slightly different. Okay, so let's jump back over to our Kubernetes cluster. So we have our pod, we have it hosting our container. If we want to host multiple containers of our application or multiple copies of our application, we would spin up additional pods. And this is what's known as a replica set. So a replica set can have one pod or it can have multiple pods. And that's how we can scale horizontally. And we need a way to create this replica set. And I already demonstrated how we do this. We use what's known as a deployment. And so we use kubectl, give it the manifest file, and then we authenticate to our Kubernetes cluster using an account, and assuming that it has the appropriate IAM roles, we can then create the deployment. So a deployment, it describes the desired state, it creates a new replica set per deployment, and you can update containers and pods, you can update pod configs, any number of different reasons. Now you don't have to use a deployment. These are really for long-running pods, something like a website. You can also do a job, which will just perform a single action for a pod and kill it, basically. So that's definitely an option. But for our application, we're going to be doing deployments. Now, we'll need a way to connect to our underlying data store. And we don't want to bake in that configuration directly into our containers. Instead, what we're going to be leveraging is environment variables. You can also leverage configuration maps if you so desire, that we can then reference something like a secret. So maybe we have something where we want to store our connection string as a secret, and then our pods can reference that secret. Now, one thing about secrets inside of Kubernetes, it's really designed for a small amount of sensitive data, so we're not talking about megabytes of data. really for something like a password, a token, or a key. But there is definitely some concerns around those secrets and in terms of access, in terms of who can create the secret, who can access the secret, who can use the secret. So if you're really concerned about something like that, there's definitely alternatives to just using a plain old Kubernetes secret. There's the sealed secrets, as well as an external secret store. So again, talk with your platform engineers, talk with your operations folks, talk with your DevOps engineers as to the approach that you want to do. For simplicity's sake, we're just using a very basic secret. So again, make it easy as possible to learn. Once you understand the core concept, you can easily replace it with whatever you want. Now we need a way to get traffic from our user, HTTPS traffic, into our pod. We want to be able to request it and host our application. And so this is where an ingress controller will appear. And so what this is doing is this is fulfilling ingress requests. And this is for our HTTP or HTTPS traffic only. And this allows us to start browsing. When I went to randomquotes.local, it made that request went through the ingress controller first. So think of this almost like a gateway. It's probably a good way to think about it. Now, generally, we don't want to have our ingress controller and our application located right next to one another, because we can have one ingress controller be used for many, many different applications. And so what we'll do is we'll isolate these in separate namespaces, which is a good way to isolate groups of resources within a single cluster. Now, I need a way to be able to access my containers, because I still don't have a way to get traffic from my ingress controller to my container. And I don't want to have the ingress controller connect directly to those pods, because as you see, we were deleting the pods and we're deleting that replica set every time we did a deployment. So this is where we would create a cluster IP. And just like everything else we've been creating, a deployment, a secret, and so on, everything's going through the cluster API to do all this work for us. What's cool about the cluster IP is it decouples this concept of our pods and our replica sets from anything else that needs to access it. And so a cluster IP, think of it like a VIP. It's really for internal access within the cluster. So if I have any sort of internal resource that needs to access my pods, I should create a cluster IP to handle that. And we access everything via a port, and we'll see that in just a second. And what we do is we actually reference the metadata. So when we do a deployment and we create a new replica set, I'm just referencing that metadata. So the cluster IP is there to handle all of that for us. Now I still need a way to get traffic from my ingress controller to my cluster IP. And this is where ingress will come into play. And again, just like before, we're creating this using the Kubernetes API and our manifest files. And this is what actually exposes the routes from outside to internal bits inside of our cluster. So this is using URL rules to route our requests. So for example, randomquotes.local. All right, so let's take a look at the manifest file in a little bit more in depth so we can kind of understand this a bit more. Again, this is a very simplistic manifest file. Chances are your manifest files are going to be a bit more complex that you're working with. But again, start simple, then go complex, don't start complex, and then try to go simple. So I have my secret that I've defined up here. And in some cases, I might actually have the secret stored in a separate file if I'm using customize or anything like that. But again, for simplicity's sake, I have it in the same manifest file. And then here, I'm defining my deployment. I'm giving it the name. And then I'm saying how many replicas of my container, or excuse me, how many replicas of my pod I want to run. I give it the ability to match against it, to find it throughout my through my service, and being able to make sure that I can make it easily findable, excuse me. And then I'm giving it the image that I want it to host. I have the resource limits and requests sitting here. I tell Kubernetes what port I want to expose for traffic. And then I'm providing my environment variable, which this is the environment variable that I've defined inside of my application, random secret phrase. And then I'm giving it the value. So I'm pulling it in from random quote secrets, and then I want to pull in a homepage display. So if we come up here, we see random quote secrets, and then I see homepage display. So this is, like I said, a very, very simplistic version of a deployment, but it covers a lot of the big stuff inside of here. It tells us how many replicas we want, shows what image, what our resource requests are, what ports we want to expose, and then the environment variables. Next up, we need to create that cluster IP that we were just talking about. So that's what we're doing here, creating a service, giving it a name, telling the type, which is cluster IP, telling it what to connect to, so in this case random quotes web, which matches up here, random quotes web. And then I'm giving it a port, an external port. And the only reason I did something different like 6801 as opposed to 8080 in both cases was just to show the difference in terms of how we're going to connect to it. And then I tell it the target port on my pods. And then finally, I define ingress. Give it the kind, give it a unique name, tell it the class name, which in my case I'm using Nginx as my ingress controller, and then I give it the host, tell it how to find it, and then I'm telling it what service I want it to connect to, and again, which port I want to connect to from here. So I want to connect to 6801 when I get traffic, and then my cluster IP will connect to 6801, and then I'll transform that to 8080, and then that's going to send traffic over to my containers or my pods. So again, this is a very simplistic way to do this. Now, in terms of the actual ingress controller itself, that itself I pulled in from Nginx. So I'll show you what that looks like. For that, what I did is I just said kubectl apply, and then I gave it a path. Let's zoom in a bit on this. There we go. I gave it the URL that I wanted it to run for me. And you can do that. So kubectl apply can be either a local file or it can be something that's external, like this. And then it downloaded and did all the work for me on something like this. Now, a couple of things about what I showed you. First up, I was using ingress for this. And one of the, I say, the trickier things about Kubernetes is that it is always changing. And in a lot of cases, there are a lot of different ways to accomplish the same thing, but with slightly different use cases or slightly different rules. So I'm going to use inbound traffic as an example. So I used ingress, and this is for HTTPS traffic only. However, ingress, if you go to the documentation, says that it's been frozen. Instead, this is being replaced with the gateway API. And so you'll have a gateway, and then you'll configure a listener, which is typically like on a TCP port or an HTTP port, and then you configure a route. And so this is that's what's ingress is being replaced by. In addition, if you want to, another option is to leverage a load balancer. And the load balancer will typically straddle the Kubernetes cluster and external resources. So you might have like an AWS load balancer, for example. But then you'll need to expose those pods to the load balancer that's external. And so this is where you'll use something like a node port. Again, all of this is meant to accomplish similar objectives, but in slightly different ways, again, based on your use case. Talk to your platform engineers, talk to your operations folks, your DevOps engineers, whoever's responsible for managing and hosting your Kubernetes clusters as to which approach they picked, and then I would go from there and learn that. All right, so I'm going to wrap it up with some things that you can do on how you can learn Kubernetes. First up, I would highly recommend just putting together a very simple application and learning about these core concepts. And then once you do that, you're going to have a much better understanding of how a lot of other different pieces of Kubernetes works, because you're going to learn about desired state. You're going to learn about how the kubectl command line works. You're going to learn about how networking works and IAM access and deployments and everything else in between. It's just a good way to kind of get a good foundation on doing something like this. And then you can switch it up and do things like gateway API, or if you want to do load balancers, if you want to do stateful sets instead of replica sets, or if you want to do jobs. A lot of the core concepts are still going to apply for what you're trying to do. If you're someone who likes to read books, I liked the Kubernetes Up and Running book. It was a good dive into Kubernetes without going super deep into the weeds like some of the other books that I have. If you prefer videos, Tech World with Nana, she does a fantastic job. She has a 4-hour video that walks through Kubernetes, and you can see it's really popular with the 7.6 million views. One thing to make note of is that it does dive really deep into the weeds at times in terms of like what Kubernetes is and how it's hosted and how to install and everything along those lines. But she does a really good job on just providing you with a good foundation of Kubernetes. And then finally, don't discount the docs. Kubernetes.io provides a tremendous amount of docs and tutorials. Now, if you want a Kubernetes cluster to just try out and play around with without incurring all the various cloud costs, you can host Kubernetes locally. If you're using Docker Desktop, well, it's super easy to spin up a Kubernetes cluster, but you're going to be doing all of your access via kubectl. Another option is to use Minikube. And one of the advantages of Minikube is that a lot of the tutorials that are out there, especially on the video side, they use Minikube, so you can just follow right along with what they're doing, so there's no differences or changes, and it's cross-platform. Now myself, coming from IIS, I have this IIS manager point of view, and so I prefer Rancher Desktop. And that's actually what I was using today. And so if you're curious about what that looks like, it provides just a bog standard Kubernetes cluster experience. I'm running a K3s cluster, and I can see a whole bunch of different things. It provides just a nice UI as to what's going on. I can see my workloads, like how many pods I have, what namespaces I have, the different services that are available. You can see the cluster IP that we created today. It's just a nice user interface, again, because I like user interfaces and be able to see it. But you can get all this information directly from the kubectl and the various logs. But it just visualizes just slightly better. And if you're looking for an application to get started with, you can go to this URL, and that's what this is. That's the application that we've been using today. Gives you all the information about how to fork the repo, where the Docker repository is, how we build it. It gives you some activities that you can perform yourself, as well as a couple of learning sessions, how to do a basic deployment. We'll talk about customize, and then how to use Argo CD. So I like using this, believe it or not. I still use it when I want to learn new things like Argo, when I want to learn CodeFresh, when I just want to learn Kubernetes, because it has no dependencies. It has some environment variables, and I inject the version number into the container, so it makes it really easy to determine if I'm actually doing something right. And then finally, selfishly, I have to promote the white paper that the Kit and I wrote about a leader's guide to Kubernetes continuous delivery at scale. So this is a good white paper for getting started with Kubernetes if you're starting to worry about how am I going to do my deployments, how do I automate that kubectl apply, but how do I do that at scale for everyone to be able to use. And that's it for today. John, have any questions come in?
So I struggle to add myself to the stage. Well, first of all, thank you very much, Bob. We really appreciate it.
Yeah, no problem.
Great job. We haven't had too many questions. Again, we're going to hang around just for a couple of minutes here. If you have a question, feel free to take advantage of the comments section. You can add your questions there. Bob will endeavor to get those answered. I just want to remind folks of some of the resources that we've highlighted. So you'll find that white paper at /whitepapers, which we already linked on the banner there as well. Or you can go to our resource, which is /Kubernetes. So this is the holding page basically for all your resources. If you want, you can take a look at these as well if you're at all curious. We have a lot of resources available there. You'll find the white paper listed here, that graphic there you can take a look at there. But in the meantime, just wanted to remind folks that we have other webinars coming up, so you can check these out at octopus.com/webinars. Just to remind folks, we've got some webinars coming up in June, which is great. And in addition to that, just to remind folks that we'll be posting a copy or a recording of Bob's presentation to our YouTube channel later today. So feel free to take advantage of that when it's available. Just taking one last thing at one last look here at the comments. Lots of links posted by Joanna. Thank you, Joanna, for those. That's great. We'll give it 1 Mississippi, 2 Mississippi.
Yeah, if you can't think of a question, Does
There we go.
Octopus
Here's a
Deploy
question.
get a CodeFresh as part of our subscription? So right now they are separate. They're sold as separate products. If you reach out to our sales at octopus.com, we'll be happy to help you out with any sort of trials or getting started with any of that type of stuff.
Fantastic. This is the thing, this is me tap dancing, by the way, waiting for questions. But as soon as one question gets answered, then this whole avalanche of questions come in. Or maybe not. Maybe this might be one of those rare occasions. So there you
and if you do think of a question after the fact, like I said, please feel free to email me or hit me up on Community Slack. I'm happy to answer any sort of questions that come up, especially after the fact. So
there you go. You guys can screen grab this if you want. Feel free to take advantage. All right. So no more questions yet. Again, going once, going twice. Anywhere you coming up? This is again tap dancing to kill time in case people are typing questions. And are you going to any events where you'll be talking about Kubernetes soon?
Yes, I will be in Kansas City where I'll be talking about Kubernetes. I will be in Lincoln talking. I think I'm talking about Kubernetes there. And then I will be flying to Hamburg to talk about Kubernetes there. So I'll be kind of all over the place.
Awesome. Well, you're getting lots of thank you notes there. So anyways, with that, I'll just go ahead and wrap it. So Bob, thank you very much. Thank you for your, we've got a question that just came in the last second here. Oh, very, very easy question to answer at the last second here, Bob. There you go.
Compare Octopus Deploy to Argo CD. Yes, so that's a fair question to ask. So Argo CD primarily is a Kubernetes tool for deployments, and the big difference between Octopus Deploy right now and Argo CD is that Argo CD is primarily a GitOps tool that's used to just handle your Kubernetes deployments. So you set it up to monitor a particular Git repo, and it'll look for the manifest files, and then if it sees that the manifest files are your your customized or Helm templates have changed, it'll go ahead and apply those types of things. The primary difference between that and say Octopus Deploy is Octopus Deploy can also monitor those items for you, but we can also handle deployments to a host of other things. So I mentioned with Octopus Cloud, for example, we host our application on AKS, but we also use Azure SQL as well as Azure File Storage. Octopus Deploy can help you deploy and configure to all of those with various different steps and perform a number of different tasks in between. So it's really up to you in terms of like what your preferences are on something like that. But ultimately, it's Argo CD is hyper-focused just on Kubernetes, whereas Octopus Deploy does Kubernetes, but a host of other deployments.
Awesome stuff. Jose is making reference here to a tool that Matt Casperson posted recently. This was, not recently, but, a few months
ago. It's a while ago.
So if anyone hasn't seen this is the Kubernetes YAML generator. This is actually something you can use today. It's at kasyaml.com, and you can take a look at this. And what it basically does is it uses the UI controls we have built into Octopus through, if you haven't seen Octopus before, these are some of the controls we have built in, and you can take a look at the various aspects of, if you don't like writing YAML, I mean, who doesn't, right? I mean, it's just such a wonderful experience. Break out the ruler.
I guess really, who remembers all of the various options inside of YAML?
That's right. To be successful with YAML, I guess just, hands and head in the hands, that sort of thing.
Yeah.
So anyways, lots and lots of various knobs and buttons to tweak, etc. You can take a look at how to generate this using a probably nicer experience. This is at kasyaml.com. This was built by Matt Casperson of our team. So
and I'm going to go out on a limb, and I suspect that they built this because our core Kubernetes step itself, not our core Kubernetes step, but one of our first Kubernetes steps was providing this sort of user interface.
Yeah.
Was they built this to test out to make sure the YAML they're generating was legitimate, and so let's just put this out there.
Fred's got another question here. To simplify YAML, what do you think of KDS 8S? That's it's the code. What is it now? The code generation kit. You can write this as code as opposed to just raw YAML. Is that right?
Oh, yeah. I haven't had much experience with that, so I unfortunately can't offer a concrete opinion on that.
Okay. Well, there you go. Anyways, one to trip us up on. Well, anyways, thanks again, Bob. Really appreciate it. We'll go ahead and end the stream now. Feel free to obviously take a look at the other webinars, as I mentioned before. But until next time, happy deployments and take care. We'll see you on the next one.